All right, so we're going to go through the three types of functions that we're going to look at and what they look like, and how we can graph some of these different types of functions. So let's see here. All right, so our three types of functions that we're going to look at specifically are linear, quadratic, and exponential. So a linear function looks like this. It is, you could use y or you could use f of x, either one. Is y equals mx plus b. That's your general form for a linear equation or linear function. Y equals mx plus b. When you graph a linear equation, it's going to look like just a line. So some type of slanted line. Let's try that again with some arrows. There we go. Some type of slanted line is going to be what a linear function is going to look like when you graph it. Linear has the word line in it. L-I-N-E. Linear line. A quadratic function looks like this. Y equals ax squared plus bx plus c. That's what the general equation for a quadratic looks like. When we graph a quadratic, it is a curve that has a U shape to it. So something like that. That is a quadratic function. Okay, then our last one, exponential, looks like this. Y equals a parentheses b to the x power. And when we graph an exponential, it has also got a curve to it, but not quite the U shape that a quadratic has. An exponential looks like this. And so it's kind of flat and then it curves up real fast. That's an exponential function. And so we're going to look at identifying these if they gave us an equation, identifying them if they gave us a table or a graph, and then actually just graphing some of them on our own. Okay, so we got the y-intercept of any function can be found by plugging in 0 for x and simplifying. So the y-intercept occurs when x is equal to 0. The y-intercept is where the graph crosses the y-axis. Where it crosses the y-axis is the y-intercept. And we can find it, like it says, by plugging in 0 for x and simplifying. All right, so for each of the following, we're going to state what type of function it is, whether it's linear, quadratic, or exponential, And then we're going to state the y-intercept for each one. So looking at that first one, y equals 3x plus 5. Which one does that look like? Linear, quadratic, or exponential? It looks like what? Linear, yes. Right, it looks like a linear. It's 3, which like in that case could be m, and then x, and then plus a number. So yes, this is linear. Now it said for us to find the y-intercept, we're going to plug in 0 for x, and we're going to simplify it. So we're going to have y equals, plug in 0 for x, and simplify. And so we got, what's 3 times 0? 0. And 0 plus 5? So 5 is our y-intercept. Now, typically we want to write these as an ordered pair. So we just said that y was 5. What's the x going to be? What did we use for x? 0. So all your y-intercepts are always going to have an x that is 0. It's always going to be 0, then a number for a y-intercept, where it's crossing the y-axis. Okay, let's look at number 2. Linear, quadratic, or exponential? It's 3 parentheses 2 to the x minus 6. Go ahead. What were you saying? Exponential, right. Because the x is the exponent, that makes it exponential. When your x is your exponent, that's exponential. And so same thing, to find the y-intercept, we're going to plug in 0 for x and simplify it. Okay, so if we're doing our order of operations, we're starting with the exponent. What is 2 to the 0 power? Is 1. Anything, doesn't matter what it is. It could be a million. A million to the 0 power is 1. Anything to the 0 power is 1. So this is going to be 3 times 1 minus 6, because 2 to the 0 power is 1. And so then we have 3 times 1 is 3, and 3 minus 6 is -3. So my y-intercept is 0, -3. Okay, let's go on to some of the next ones here. Oops. There we go. Yep. All right, what about number 3? What is number 3? Linear, quadratic, or exponential? Quadratic. How'd you know? What about it makes it quadratic? There's one little key thing. You said is what? Complicated. Okay. The key thing that makes anything quadratic is having an exponent of 2. If it has a highest exponent of 2 for the variable, that makes it quadratic. All right, but yes, it does look a little more complicated than the other ones. And so this one is quadratic. Okay, if we're going to find that y-intercept, we're going to plug in 0 for x and simplify it. So 0, I got to plug it in for both of my x's. So during my order of operations, I start with my exponent. What is 0 squared? 0 squared means 0 times 0. 0. If it had been an exponent of 0, then I would have said, yeah, 1 works. All right, so then we're going to do some multiplying. We got 3 times 0. 0. 5 times 0. And then we'll go 0 minus 0 is 0. And 0 plus 7? 7. So my y-intercept for this quadratic is 0, 7. Hey, what do we think for number 4? What type of function does number 4 look like? Linear, right. If we had kind of rewritten this kind of in the form that they had, we could say it was y equals negative 2x plus 9. That would be the same equation there if I wrote it in that mx plus b form. If I'm going to find my y-intercept, I'm going to plug in 0 for x. And I'm going to write it once it stops spinning. So this is going to be 9 minus 2 times 0. So this is going to be 9 minus, what's 2 times 0? 0, and 9 minus 0? 9. So my y-intercept is 0, 9. Hey, what does number 5 look like? It's got a highest exponent of 2. Quadratic. Quadratic function. And I'm going to plug in 0 for my x's, and I'm going to simplify it. So do my order of operations. I start with my exponent. What's 0 squared? 0. All right, might as well go ahead and do my multiplication here. What's 4 times 0? 0. We got 0 plus 0 is going to be 0, and 0 minus 1 is going to be negative 1. So my y-intercept is 0, negative 1. Okay, got a few more here to try. Number 6, what does number 6 look like? Linear, yep. I'm gonna plug in 0 for x and simplify. So we got 6 times 0 is 0 plus 7. So y equals 7. So my y-intercept is the 0.07. All right, number 7. What is the exponential? Very good. It's got that x as my exponent, so that makes it exponential. All right, again, we're going to plug in 0 for our x and simplify it. 4 to the 0 is what? 1. So then we got 1 plus 7? 8. So my y-intercept is 0, 8. Okay, one more on this page. What is that one? Y equals 8 plus 2 to the x. Exponential again, yep. It's got the x as the exponent. We'll plug in 0 for x. So 2 to the 0 is going to be 1. So then we got 8 plus 1, 9. 0, 9 for our y-intercept. We are. Mm-hmm. All right, you do 9 and 10. You try 9 and 10 on the next page. So what did you decide number 9 was? Quadratic. Yep. Is that what you're going to say, Garrett? Cool. Good. It is quadratic because of that exponent of 2 right there. So then to get the y-intercept, you plug in 0 for x. We got 0 squared is what? 0. And 0 minus 5, negative 5. So my y-intercept is 0, negative 5. Okay, last one, number 10. What is number 10? Exponential, very good. It's got that x as an exponent, that makes it exponential. So we're going to plug in 0 for x. 3 to the 0 power is what? 1. And 2 times 1 is? So my y-intercept is 0, 2. Any questions on looking at an equation and determining which type it is? Or finding the y-intercept? Okay. So now let's look at the graphing part of it. So actually being able to graph some of these. So here we go. Here's our first one. So we're going to graph them using a table. All right, so we're going to make a table for each one. All right, and then use that to help us plot those points and graph it. All right, so let's first answer these first two questions. What type is this number 1, and what's the y-intercept? What type? Y equals 3x plus 2. The one that starts with the what? Linear, very good. So this is linear. Starts with an L. And then the y-intercept, I'm going to do what to find it? Plug in that 0 for x. So this is going to be negative 3 times 0 is 0, right? Plus 2 is 2. So my y-intercept is the ordered pair 0, 2. If we look at our table, I think that's one of our points, don't you think? Look, right here, when x is 0, we already know y is what? 2. So how in the world am I going to find out these other y's? Yeah, instead of putting in 0, we'll put -2, right? Instead of putting in -2, we'll put -1. So we're going to take each one of these x values, plug them in for my x to get the y. So we'll start there with -2. So we'll go -3, plug in a -2, plus 2. What's -3 times -2? 6. Plus 2. So this first ordered pair is -2, 8. You with me, Tyson? Okay. Let's make sure our phone doesn't distract us. All right, then we'll go to -1. Do the same thing. We're going to plug in -1 for x and simplify it. Okay, -3 times -1. And plus 2. So -1, 5. Then we already did 0, so now we'll go to 1. You can go ahead and start working that one out. I'm waiting for my computer to stop freezing up. Plugging in 1 for x and simplifying. There we go. So -3 times 1 plus 2. So what's -3 times 1? -3 plus 2. -1. And then our last one is 2. So plug in 2 for x. -3 times 2. -6 plus 2. -6 plus 2. -4. And so we're going to plot each one of these points to get our graph for our line. So we'll go -2 and then up to 8. There's a point. -1 and up to 5. 0 and up to 2. 1 and down to -1. And 2 and down to -4. And try to connect them the best you can. I'm going to cheat and use my line tool here. There is our line, our linear line, -3x plus 2. Any questions on how we did that? Okay, here's number 2. Okay, number 2 here. Let's first do the type and the y-intercept. What type is number 2? Quadratic. It's got that exponent of 2, makes it quadratic. How are we going to find the y-intercept? Put 0 in for x in both places. And so we got 0 squared is, and 2 times 0, 0. And then 0 plus 0 is 0, and 0 plus 5 is 5. So my y-intercept is 0, 5. And if I look right there, that's one of my x's in my table. Here's x is 0. So I know already y is going to be 5. How are we going to do the rest of them? Replace those x's with each one of these numbers. So we'll start with -3. So -3 goes in. -3 squared. What do we get? 9. Right? Make sure you remember, anytime you square something, it's always positive. Always. All right, let's go ahead and do what's 2 times -3. Then we'll do 9 minus 6 is what? Plus 5? 8. Next, we'll go to -2. Do the same thing. Plug it in for both of my x's. -2 squared. 4. 2 times -2. This thing really makes me angry. Come on. All right. And okay, so we got we got 4 minus 4. 0. 0 plus 5. 5. Okay, next we got -1. So -1 goes in for my x's. -1 squared. 1. 2 times -1. -2. 1 minus 2. -1 plus 5. 4. All right, and we got one more. I'm running out of space down here, so I'm going to go up here above my graph. I'm running out of space there. So now we're doing 1. So 1 goes in for my x's. All right, what's 1 squared? 1. And 2 times 1? 2. Okay, 1 plus 2? 3. 3 plus 5? So these are going to be my 5 points I can use to graph this quadratic. So we got -3, 8, -2, 5, -1, 4, 0, 5, and 1, 8. We're going to try to connect them best we can with something that looks kind of U-shaped. So you can see mine is not perfect either. That's okay. It's close enough. Okay, let's keep moving right along. Here's number 3. What type is number 3? Exponential. Now we're going to find the y-intercept. So we're going to put 0 in, and 3 to 0 is going to be, it is 1. Yep. So we got 0, 1 for our y-intercept. And that I see as a point in my table right there, 0, 1. All right, next we got to plug in each one of the other ones. So we got to start here with -2, right? Might want to try to use the calculator for this one. You put 3 to the -2. Let's see. Here we go. I'm gonna open up Desmos. So 3. Oops, so first -2. 3 to the -2, it says is 0.1111 repeating. Is that what you got? 3 to the -2? Sure. You take my word for it, right? Okay. All right, so we got 0.1 repeating. I'm gonna put my little bar above it. We're gonna have to approximate it. Do as close as we can. All right. Then we got 3 to the -1. Here it goes, freezing again. Come on, wake up. Come on, there we go. Except for it wasn't supposed to be like that. It's supposed to be a 3 to the -1. All right, so I'll do the same thing. I'm gonna go in Desmos calculator here. 3 to the -1 is 0.3 repeating. So 0.3 repeating. Then I've got to do 1. So 3 to the first power is 3 to the first power. 3. And then the last one is 3 to the second power, which is 9. All right, so yeah, we are going to have to do some approximating here for doing 0.1 and 0.3. All right, so let's see. -2 and 0.1. I'm going to try to go like just above the x-axis and say that's 0.1. And then for -1 and 0.3, I'm going to go just a little bit higher than that. And then we got 0, 1, which we can graph right there. And then 1 and 3, and 2 and none. And again, kind of like the quadratic, I'm going to try to get my best little curve connecting all of those points. Yep, it's a little bit wobbly, but good enough. Any questions on number 3? Okay. Where am I at? What am I doing? Right here. All right, here we go. Number 4. What type? It is? Quadratic. Okay, it's got the highest exponent of 2. So that makes it quadratic. Okay, and we're going to plug in 0 to get our y-intercept. So let's start with our exponent. We've got 0 to the second power. 0. We got -2 times 0. 8 times 0. 0 plus 0 plus 2. 2. So my y-intercept is 0, 2. And if you notice, that's actually the first part of our table. So I'll go ahead and fill that in. Okay, next we're going to do 1. So that's our next point in our table. So I'm plugging in 1 for my x's. You can do in my order of operations. I'm going to start with my exponent. What is 1 squared? 1. And then I've got -2 times 1. Yep. And 8 times 1. 8. So we got -2 plus 8. 6. And 6 plus 2. 8. And next we're going to go with 2. You go ahead and start trying to do 2 while mine stop freezing. Okay, so now we're doing 2. So 2 in for my x's. And so we start with our exponent. What is 2 squared? 4. All right, we've got -2 times 4. -8. And 8 times 2. Negative 8 plus 16. 8 plus 2. 10. So we got 10 there. And then we're going to do 3. And so plugging in 3's for all my x's. So let's see, start with 3 squared. What's 3 squared? 9. We're going to have negative 2 times 9. 8 times 3. 24. Negative 18 plus 24. 6 plus 2. And last one is 4. Anybody want to take a guess of what they think it's going to be? Think it's going to be 2? I think I might agree with you on that one. Let's see. So let's see. 4 squared. 16. Negative 2 times 16. Negative 32. 8 times 4. 32. Negative 32 plus 32. 0 plus 2. So we were right. So you notice there in those quadratic ones, if you go back to, what was it, number 2 that we did those repeat like that? So that's how you can tell in a table that it was quadratic. You look for those values that are repeating like that. All right, so let's plot these points, and then I think I'm going to call this the last one of the graphing that we're going to do. So I think you guys got it, it sounds like. So let's see, 0 and 2, 1 and 8, 2 and 10, 3 and 8, and 4 and 2. And notice this one opens upside down. So sometimes our quadratics can do that. They can open downward. Oh, that is so bad. So hard to draw on this thing. Oh, okay. There we go. That wasn't terrible. Any questions about graphing? Okay, so we're going to skip 5 and 6 and go to this last little part that we got to talk about. And I think this is going to go pretty quickly because I think we kind of understand what's going on here. Depending on, we already know what to do to figure out which one it is from an equation, right? We look for the square, we know it's quadratic. We look for the x that's the exponent, then it is exponential. If it's just the x, it's linear. We know what they look like in a graph. We know the linear is going to be a line, the quadratic is going to have that U shape, and the exponential is going to be that curve, right, kind of going up. But how do you look at a table and know which type they're going to be? Well, for a linear, you're going to be looking for, did they add or subtract the same number to get to the next number in the table? So for instance, to go from 8 to 5, what would I do? Subtract 3. To go from 5 to 2, subtract 3. The same thing to go to -1, and the same thing to go to -4. This thing, just chunk it across the classroom. Waste so much time waiting for it to stop freezing. Okay, and I didn't write 1. I'm pretty sure I wrote 3. All right, same thing here, -3, -3 each time. What about the x's? How do you go from -3 to -2? You add 1. -2 to -1. You add 1. -1 to 0. Add 1. 0 to 1. So if in a table, I see that on the Y column, they're adding or subtracting the same number each time. And on the X column, they're adding and subtracting the same number each time. That's how I'm going to know that it's linear if I'm looking at a table. If it's quadratic, right? We already said that we know in an equation we're going to look for that squared. That squared tells us that it is quadratic. We're looking for the U shape. If we're looking at a graph, that tells us what's quadratic. What from a table have we talked about tells us it's quadratic? Right, look at this table that you got right here. It repeats. So look for repeating Y values. If you see those Y's repeat themselves, that's going to tell you that it's quadratic. That's how you get that U shape, right? Because it goes down and then it comes back up because you're going to get the same Y value again. So look for repeating Y values. Right, and lastly, exponential. And we know in an equation we're looking for the X as an exponent. And for exponential graph, we're looking for that curve, but not quite a U, because the U is quadratic. How in the world are we going to know it's exponential by looking at a table? Ignoring the fractions for a second, how do you go from 1 to 2? You add 1, okay. Could you do it another way besides just adding? Multiply by 2. If we go from 2 to 4, you multiply by 2. All right. Let's think about this. If I did 1/4 to 1/2, do you think that's going to be times 2? Let's see. 1/4 times 2. That's saying 2/4, which is what? 1/2. So times 2. To go from 1/2 to 1, 1/2 times 2. That's 2/2, which is 1, right? So if it's exponential, we're looking for, do they multiply the same number each time in the Y's? If they multiply by the same number each time in the Y's, that makes it exponential. So linear, adding, quadratic, repeating Y's, exponential, multiplying by the same number each time. That's how we know the difference between the three if we're looking at a table. Okay, so that's what these last examples are going to have us do, is look at these different types and tell us what we think it is. So they're going to look at some tables here. Looking for patterns in this table. Okay, what's the pattern in the X's? +1. Each time they're adding 1. +1 for each of the next ones. What about this? It says g of x, but remember, this is like saying y, because it's just function notation. Are they adding the same number in the y's? How do you go from 10 to 17? Add 7. If I add 7, do I get 24? Yeah. Do I add 7, do I get 31? Add 7, do I get 38? So I'm adding the same number each time for both x's and y's. That makes it what? Adding the same number each time. Linear. Can you look at that table and tell me which one's the y-intercept? Which one? What is it, Garrett? 10. 0, 10. We're looking for when is that x equal to 0? Remember that's function notation? It's what we did on Friday that you hadn't watched yet. Go back and watch that video from Friday. All right, let's look at number 2. Look at that table. Do you see any type of pattern there? Look really carefully at the y's. Which is what type? Quadratic. Yep. So you got those repeating y values because you got 5 and 5, 2 and 2. That's quadratic. Repeating y values is quadratic. What do you see the y-intercept in that table? It's 10 again. 0, 10. When my x is 0. Okay, let's see, I think there's a few more here. Well, these are easy ones because these are looking at equations of the graphs. Number 3, what type? Linear. How are you going to find the y-intercept? So you're going to have 2 times 0 is plus 4. 0, 4. Hey, what about number 4? Quadratic. How do you know, Jordan? Right, it's got the exponent of 2. That makes it quadratic. And we can do the same thing, plug in our 0 for our x. Come on, don't do this. Minus 3 times 0 plus 5. So let's see, we got 0 squared is 0. Why do I keep writing plus, not minus? Okay. And then we got 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. 0 plus 5 is 5. So 0, 5. Okay. And let's see here, number 5. What is number 5? Exponential. All right, it's a little bit hard to read that graph. Where is it crossing? This is my y-axis, my vertical one. Can you see what that point is? -5? 0, -5. All right, let's quickly run through those last 2 there. 6 and 7. Any pattern to that table in number 6? They're timesing by 2 each time, okay? So that makes it what type? You sure? Let's help them out. What is it when you multiply the same number each time? Exponential. Exponential is when you multiply by the same number each time. Do you see the y-intercept in the table? What is it? 7. And lastly, number 7 is got an exponent of x. exponent of x is exponent of x.